Hello, everybody, and welcome to our last lesson of our review chapter. This is section 0.5, where we are going to be looking at simplifying functions, and we're going to be working with fractions a bit as well. So before we work on actually writing functions for word problems and things like that, we're going to just do a quick review of function notation and how these functions should be simplified. Um, this is probably one of your more important sections of this chapter in terms of moving forward in the course. So if you do not know how to work with function notation, the very first calculus chapter we do, which is chapter 2, is going to be very difficult. If you don't know how to write an equation for a word problem, there's a chapter later in the year that you are going to find very difficult. So these are skills that you should know how to do. We basically you spent a bunch of time in grade 10 writing equations for very basic word problems and doing basic function notation. And then in grade 12, when you did chapter 10, composite functions, you dealt with more function notation and you would have had to write equations for word problems throughout the course. So our first example is if we have this g of x, this function in terms of x, of 1 over x plus 2, if I ask you to find g of 2, what that is really asking, and this might seem overly simple at this point, but that's really saying I'm going to replace the x with a 2, which means this x in the function needs to be replaced with a 2. This means I'm going to have 1 over 2 plus 2, which gives me 1 over 4. This should not be a problem for any of you. This is going to be like, Miss Woolley, what are you talking about? This is calculus. Why is this so easy? When I get to the next part, probably about a third of you are going to go, I don't know what I'm supposed to do here. Again, I've replaced this x in the function with an x plus 4. That means the x in the function gets replaced with an x plus 4. This is going to equal 1 over x plus 4 plus 2, or 1 over x plus 6. Okay? Again, some of you are probably still sitting there thinking, okay, we know how to do this. That's super simple. What's your point? And my point is, by the time I get to the next one, as soon as you don't have an x, but you have another variable, this is going to throw another chunk of you off. So again, if I'm replacing the x in my g of x, then the x in my actual function I was given must be replaced by all this stuff. So instead of g of x, or g of 2, or g of x plus 4, I have g of 3 plus h. So instead of having 1 over x plus 2, I'm going to have 1 over 3 plus h plus 2, or 1 over h plus 5. Okay, now this is why this is important. We have this notation here where we are being asked to evaluate and simplify. Now, again, in this portion, this is going to seem fairly straightforward and the answers are going to look really messy. When we get further into the course, you will be asked to do questions like this, but then you're going to be told that h is 0. As it stands, you cannot have h as 0 because it's on the bottom of a fraction. You're going to have to simplify this properly so that you do not have that anymore, okay? So when I do g of x plus h minus g of x over h, I want this fully simplified. I should see no fractions in fractions. I should see anything factored or expanded and simplified where necessary. If you still have a fraction in a fraction, you did not finish, you did not do the question, you did not complete, okay? You must make sure that this is simplified to one fraction with one numerator and one denominator, okay? So first, we know that g of x is 1 over x plus 2, and g of x plus h would be 1 over x plus h plus 2. So where people run into problems with this is the x plus h throws them off. A lot of people tell me that this is 1 over h plus 2. It's not. G of h would be 1 over h plus 2. Again, if I replace this x with an x plus h, This x must be replaced with an entire x plus 8. Once I do that, now I can actually plug those into here. So g of x plus h is 1 over x plus h plus 2 minus 1 over x plus 2 all over h. Now on the top, I'm going to need common denominators to be able to simplify the top here. My common denominator, I would need to multiply the left-hand fraction needs to be multiplied by x plus 2. The right-hand fraction needs to be multiplied by x plus h plus 2. And this is all over h. You could choose to write this as times 1 over h instead if it helps you. So remember that when you're dividing by something, that's the same thing as multiplying by the reciprocal. And so when you have these big messy sections here, it might help you to rewrite it as multiplying by the reciprocal. Now on the right-hand side, we're going to want to expand this negative into the brackets so that we can rewrite this numerator as one giant numerator. So I have x plus 2 on the left minus x minus h minus 2 on the right, all over one common denominator times 1 over h. Now I can simplify my numerator. 2 minus 2 goes away. X minus x goes away. And I end up with negative h over x plus 2, x plus h plus 2 times 1 over h. Now the h that's isolated on the top can simplify with the h from the bottom. This would leave us with negative 1 on the top and x plus 2 times x plus h plus 2 on the bottom. Okay. This would be our final answer. Okay. So if I had been told in the question h was 0, I can put h is 0 in here now. I couldn't when I started, but I can now. Okay, so that's it for our function notation. There's practice questions in your board questions and in the worksheet that's provided to have a little bit more practice with those function notation questions. The next step is problem solving. So the big problem is you can't solve the problem if you have no equation to work with. So you have to be able to write your equations, okay? So this question is a water tank has the shape of an isosceles triangular prism, C diagram. Let x represent the depth of water. So let's draw in some water here. Okay, so x is going to be the depth of the water. Okay. It says express the volume of the water as a function of x. Okay, so first we need to know, well, how do I find the volume of a triangular prism? Volume is going to be always the base times the height. So the base is a triangle, and so you get half base times height of the triangle times the length of the prism. Okay, so this is the height of the entire triangle. This is the base length of the entire triangle, and this would be your length of your prism. Okay, so the problem is that we're trying to express the volume of water as a function of x. So we've got three variables here. If the tank is full, these are our three values. But as the water rises and falls, the height changes, but so does the base of the triangle. Our base of our triangle is this distance here. Okay? So if the water falls and rises, so does this, this value changes as well as x. Okay? So B and X have some sort of relationship here, and we need to figure out what that is. So we know that in our original question, when B is 50, H is 75, right? So if B is 50, H is 75. Okay. Now, if I draw myself a picture that indicates this, okay, if this is 50 and this distance is 75, if I change this height and I draw myself, say, a new triangle here, right? Using similar triangles, the angle in the corner is the same and this one's still 90, which means this angle in the corner must be the same as well. And that means that you must have, basically you have this triangle here, and then you have this triangle here that must have proportional side lengths, okay? So if I take a look at my base, my original base here, 50 is 2/3 of 75, or B is 2/3 of my height. And that relationship must be maintained by similar triangles. If this is my B value and this is my H, this B and this H must have the same proportional relationship, okay? So what that means is that when I make an equation for my volume, I know the height in my little triangle is actually called X, okay? So I would have half. Instead of having B, I actually have 2/3 X times X because my height of my water is X. Okay? My base of my water must be 2/3 of the height. And then the length of this thing stays the same no matter where I am in my tank. Okay? So this length here stays constant no matter the height of the water. The tank is not getting any shorter. Okay? So what that means is that I actually have V equals 1/2 2/3 x squared times 150. The 2's can cancel out, and 150 can be divided by 3. And therefore, we have a volume of water as a function of x. Okay? As a function of means that's your variable inside your function. Okay? So we've got one more question here. All right, so we have a square inscribed in a semicircle as shown. Write r as a function of x. So this means we're going to have r equals, and then in here our variable is x. Okay, we write it in function notation. Actually going to be r of x. So like our previous one would have actually been v of x. I can, erase here. My computer will work. Nope. All right, I'll fix it later. So this means that we want to figure out what r is, okay? So I know that if this is a square, I know that these sides okay, let's try this again. I had to restart my Word program here, so we're might look a little bit different than yours. So what I know is if I have a square inscribed in my semicircle, is that these sides must all be the same length. So what that means is for my triangle here, this here must be half of x, right? It's half of that side length. Okay. So then I know from Pythagorean theorem, a squared plus b squared is c squared. So r squared would be x squared plus half x squared, or x squared plus x squared over 4, or 5x squared over 4. I'm trying to write r as a variable as a function of x. So my variable is x. I need to isolate r. So r would be square root 5x squared over 4. The reason I'm not going to put plus or minus in front is because you wouldn't be able to have a negative radius of your circle. So I don't need the little plus or minus here. That's not necessary. Okay. Now I'm going to fix this up and rewrite this as root 5 over 2x. I have succeeded. R is written as a function of x. Now, the question was, if this is linear, state the rate of change. This is linear because x is a degree of 1. So my rate of change, remember, is slope, which in this case would be root 5 over 2. Okay. We will be dealing with rates of change and slopes of lines a lot. Almost our entire semester is based on this idea of rate of change. So that's key that you know that rate of change is your slope of your line. Okay. So take a look at the board questions and the worksheet, and make sure you're comfortable with function notation, and make sure you are comfortable with writing equations for work.